For the loaded beam shown in figure, find the deflection at free end and the maximum deflection between the supports. Take E is equal to 200 kilonewton per mm square and I is equal to 9 into 10 raised to 6 millimeter raised to 4. Right? So this is the numerical. Now the first step we need to do in the Michaelis method is to find the support reactions, right? So let us start with that. Support reactions, uh, taking about point A, right? I'm taking moments about this support. So I will have reaction at B. So it is RB into perpendicular distances 1 plus 2 3 plus 2 5 into 5, and other loads are vertically downward, so they will be negative and that will be equal to 0, so I will take it on the other side and write it as positive. 5 kilonewton, that is at this point C, into length AC. So AB is 5 plus 2 is 7, right? Plus the intensity of UDL is 4. So 4 into this length is 2 meters. So this is the total load because of the UDL, and this is acting at the midpoint of D and E. So midpoint of D is 2 by 2, that is 1 meter from D. So from A it will be 1 plus 1. So into 2, correct? RB is equal to, or I'll take this next line, 5 into 7 plus 4 into 4, 51 by 5, 10.2, right? 10.2 kilo Newton. Now the total load on beam is equal to 4 into 2 meters, this is the UDL, plus I have 5 kilonewton at the end. So this will be 4 2s are 8, 8 plus 5, so that will be 13 kilo Newton. Now RA plus RB should be equal to 13, or RA is equal to 13 minus 10.2 is 2.8. Okay, I got the support reaction. Now what you have to do, see the methodology is same, you don't have to change anything from what we did. So we have to consider a section X which is in the last section of the beam. Now how many sections are there? AD is one section, D is another section 2, EB is 3, BC is 4. So in this section BC, I have to consider a section XX, right? Now my UDL is neither starting from A nor it is starting from C. So it is in between in the span of beam. So I have to do the same construction what we did yesterday. If you remember, this was the numerical, right? So the UDL was in between. So we extended till the section XX. This was the XX. So from here to here, I extended it. So I will be doing this similar construction here also, similar modification here in the load diagram. Extend this UDL till this section XX, and also apply a opposite UDL, that is from the bottom here, right? So by doing this, we will be able to solve this. So just made this diagram. So this is section XX. So I have extended this UDL, which is 4 kilonewton per meter, till this section XX, and I have also applied another UDL which is acting below the beam in upward direction, and the intensity is again 4 kilonewton per meter, right? So I will just take this there. Modified is shown below. Okay, so this is my modified beam. Now based on this, I am going to solve the numerical. Now what I have to do, first I will find the bending moment at this section XX. Is given by, okay, let me call this as mx. This is capital M and x, and this is equal to, now I am taking moment about this section, so I'll start from here. So this is upward, so this will be positive. So RA value is 2.8. It will be 2.8 x. Then what else is upward? There is one more upward force here. This is 4 kilonewton meter, or I will take this now. So this is downward. So this will be minus 4 into this length is x minus 1. So x minus 1, and it is acting at a distance of x minus 1 by 2, right, somewhere here. So it will be x minus 1 into x minus 1 by 2, or I will make it as x minus 1 whole square by 2, correct? So this is the UDL of this, plus this one, this is upward, so that will be again 4 into, or I'll just copy this, it is x minus 3, right? Instead of x minus 1, it will be x minus 3 plus, I have another reaction at B, RB, and the value of RB is 10.2 kilonewton. So it is 10.2 into x minus 5, right? And this is in kilonewton meter. The bending moment what I have calculated is in kilonewton meter. Also the BM at XX is given by, what is the other equation? Mx is equal to EI into d square y by dx square, right? So ei d square y by dx square will also give the bending moment. Now what we have to equate this. We get ei d square y by dx square is equal to this complete equation, correct? So this is my equation which I have to integrate now. Integrating above equation, we get now what do I get? It will be ei dy by dx is equal to 2.8x is there, so it will become 2.8x square by 2, right? Minus this 4 by 2 will be 2, right? 2x minus 1 whole square, so it will be 2x minus 1 whole cube by 3. So it is 2 by 3. Just take this, x minus 1 whole cube, right? Then I have 4 by 2, so that will also be 2 x minus 3 whole square, so that will be x minus 3 whole cube by 3, so plus 2 by 3 x minus 3 whole cube, right? Plus 10.2 x minus 5 whole square by 2. So I'll just copy this here. 10.2 whole square by 2, right? Plus constant of integration C1. I'll take this next slide because I'm very long there, right? So this is my first equation. Now what I have to do, I have to integrate this once again. So I'll call this equation as 1. Now integrate this equation again. We get ei into dy by dx will become y is equal to, this is 2.8 by 2, so it will be 1.4. X square will become x cube now. X cube by 3 minus, I'll just copy this. Better copy the entire thing and just modify it here, right? So this will become x minus 1 raised to 4 by 4, so this will be 3 into 4, like this. Then this will be 2 by 3 into 4 x minus 3 whole raised to 4. This will be 10.2 x minus 5 whole cube divided by 2 into 3 plus c1 x plus another constant c2. So you got a very long equation now. There are many parameters, so we need to be a little careful when you are substituting the values. So I will call this equation as number 2. Now I have two boundary conditions. What are the two boundary conditions? At support A, the deflection is 0, and at support B, the deflection is 0. Right? Now, applying boundary condition at support A, that is x is equal to 0, y is equal to 0. Right? So I have to apply this boundary condition. Where should I apply? I will apply in equation 2, so that my left hand side becomes 0 and I can find either C1 or C2 from this. Right? So in equation 2. So what do I get? We get EI into 0, so it will become 0 is equal to 1.4 into x cube, so that will become 0 because there is x. 0 minus 1, so this will be negative, so this will also be 0. This term will also be 0 because x minus 3, so plus 0. This term will also become 0 plus 0. C1 into x, x is 0 plus 0 plus C2, right? Or C2 is equal to 0. So I found the C2 now. Now I'll apply another boundary condition. Applying boundary condition at support B, that is x is equal to, what is the length of x there? 1 plus 2 plus 2, that is 5 meters. X equal to 5 meter. Y is again 0. Correct? Now substitute that value in equation 2. In equation 2, what do I get? We get left hand side will become 0. 0 is equal to 1.4. I'll just copy this. I'll get all this, right, except for this term, because here 5 minus 5, it will become 0. So I have to just remove this one term. All other terms will be there. Here I'll put this value as 5. This will be 5. Oops. This is 5. This is 5. And C1, it will be 5 C1. Right? Now let me just try to solve this. This is 1.4, sorry, 1.4 into 5 cube by 3 minus 2 into 5 minus 1 is 4. 4 raised to 4 by 3 fours are 12 plus 2 into 5 minus 3 is 2. 2 raised to 4 by 3 fours are again 12. So this quantity is 18.333. This goes on the other side, it will become minus 18.33, and divide this by 5. So C1 is 3.67, or C1 is equal to 3.67. Okay, so I got C1 and C2 value. Now I can find the equations. Now see, in the question he has not asked deflection, he has not asked the slope, right? He has asked to calculate only deflection at support A, B, the maximum deflection between support A and B and at point C, right? So don't waste time in calculating the slopes here. So I need only deflection. However, to find the maximum deflection between the supports, I will have to use this equation. So basically we will need both equation. So let me just write the general slope equation and general deflection equation. Therefore, equation 1 becomes EI dy by dx. This I'll make it as 1.4 x square. 2 by 3 I'll just keep it as it is. 10.2 by 2, so it will be 5.1 into x minus 5x square plus C1 is, sorry, this is minus, this will be minus 3.67, right? So this is equation 3. Equation 3 is the general equation. Also equation 2 now becomes, what is equation 2? It is this. So basically I'm substituting the value of C1 and C2, and I'm just simplifying few terms that can be easily written. So 1.4 by 3, so let it be like this. This 2 and 4 gets cancelled, so this will be 2 into 3 6. Just remove this by 6, right? Same as with this, by 6. This is 10.2 by 6, 1.7. Into this value. C1 is minus 3. minus 3.67 x, and C2 is 0, so remove that. This will be my equation 4. Equation 4 is the general deflection equation. Now deflection at the end, what is that point? C. Free and C, that is x is equal to, what is the value of x? This is entire length. I need to take 2 plus 2 plus 6 plus 1, 7. So x is equal to 7. Now I have to use this equation and I substitute x as 7 in this. I will get the deflection. Now before this, I need to calculate the value of EI in kilonewton meter square, right? So EI is equal to, what is E in this? Is it 200? 200 kilonewton per mm square, right? So it is 200,000 megapascal. So I need to put it in kPa. So it will be 200 into 10 raised to 6 kPa. So 200 into 10 raised to 6 kPa, right? This multiplied by I. I is how much? It is 9 into 10 raised to 6 mm raised to 4. Now to convert mm raised to 4 to meter raised to 4, I need to multiply this by 10 raised to minus 12, right? So it will become 9 into 10 raised to minus 6. So this is 9 into 10 raised to minus 6, right? So minus 6 and plus 6, it will become 0, 10 raised to 0, so it is 1. So 200 into 9, that will be my EI. So it is 1800. 1800 kilonewton meter square. This is my EI value. Now we need Y. YC, right? So YC is equal to, EI will come on the other side. So it will be 1 by EI is 1800 into, I will open a big bracket there and copy this entire equation. So all the terms will be valid in this section because no term within the bracket is going to be negative or 0. Right now I have to just put x as 7 in all these places. So this will become 7 cube. This is 7 minus 1. This will be 7 minus 3. This will be 7 minus 5. And this will be into 7, right? So this is equal to, now let me just calculate this. Okay, 1.4 into 7 cube by 3 minus, this is 7 minus 1, it will be 6, 6 raised to 4 by 6 plus 7 minus 3 is 4, 4 raised to 4 by 6 plus 1.7 into 7 minus 5. 7 minus 5 is 2, cube of that minus 3.67 into 7. So that is this much, minus 25.35. Whole thing I need to divide by 1800. So it is minus 0.141. Minus 0.141 meter or YC is equal to, copy this, 14, sorry, it is, and next is 0 there, so it will be 14 point minus 14.1 mm, right? So that is the deflection at the free end. Now in order to find the deflection between the supports, right, what you have to do is I have to use this equation, general slope equation, and the slope at maximum deflection will be 0, right? So I'll just copy this. We know that the slope of the beam will be 0 at maximum deflection. So put dy by dx equal to 0 in equation 3. We get, right, so this will become 0. Now you have to solve for x in this, right? Now I better use my calculator because it will be difficult for me to do otherwise. So it is 0 equal to, you also can try now, 1.4 a square minus 2 into a minus 1 cube. Okay, there is one more thing. This term will not be applicable because the support is x is equal to 0 to x is equal to 5. So this term should be neglected. So this term I have to drop it from here. or let it be there. Let it be there. Let us see how to work it. So a minus 1 whole cube plus 2 divided by 3 into a minus.
Sir, x is equal to 1.89 and x is equal to 4.25.
How did you get two values there? What form of equation you used?
Sir, this only same.
No. How did you solve it?
So direct putting in calculator.
Yeah, but you should get one value of x. No? I don't think you will. Let me just do it.
Okay.
How much did you say? 1 point?
89.
Okay, I'm getting more. 1.89, right? So it will be some
Yes, sir.
value.
Sir, we have to neglect that term now that you have been selected. That
Yes. You have to neglect this term. This time you have to neglect it.
yes, sir. So then we are getting sir 1.89.
Yeah. So solving, like this, x is equal to 1.89 meter. Now you have to put x as 1.89 in this expression. You will get the deflection. I'll just say y will be 1.89. Someone please try to do this on Kelsey. 1.89. Okay, this will be negative. So I'm going to drop this term, right? This is also going to be negative. So drop this term. This will be there. So into 1.89. Okay, and this entire thing 1 by 1800. That is my EI value. Okay, let me try this. 1.4 into 1.89 cube by 3 is this minus 0.89 raised to 4 by 6 minus 3.67 into 1.89 is by 1800. So it is 0.0022. Did you get this? Minus 0.0022 meter.
0 minus 0.002161.
Yeah, 216. I just rounded it off to 22, or it will be 2.2 mm, or y is equal to minus 2.2 mm, right? Negative sign indicates that the deflection is in the downward side, right? Here also the deflection is in the downward side. So the beam is bent something like this. right? So the beam is bent like this. Here also it is bending. Here also there is sagging bending moment, right? So in this kind of beam, there will be definitely point of contraflexion. In unit number 2, we have seen that we will get point of contraflexion, definitely.